So welcome to today's session. So under the artificial intelligence subject, we are going to start today onwards Unit 4, a series of lectures on the Unit 4, and today's topic is natural language for communication. So under this topic, we are going to cover the contents, that is introduction part of NLP, generative capacity. Under the generative capacity, we are going to cover the types of grammar, that is unrestricted grammar, context sensitive grammar, context free grammar, regular grammar, and the lexicons of language, and pairs tree for sentence formation, over generation and under generation of grammar. These are the topics that we are going to cover in this particular session. Let us start the definition part. So what is what is a natural language processing? Natural language processing is a subfield of artificial intelligence that focus on the interaction between the computers and the human language. So here the natural language is not only with the computer and human. So in the artificial intelligence, we are going to discuss about the basically agents. So the communication between the agents and the computer, agents and the humans. So human communication will be in the some language, and the agent will understand that language, means it should be familiar with this particular language, the human being's language. So for that a separate processing system is required. Processing capability should be adapted to the agent, that is natural language processing. So in the natural language processing, it basically concentrate on the study. It will be discussed on the study of grammars of the communication language, that is human communication language, which provides in the grammar, means it will provide the how to construct a sentence, the structures of the sentences. So how to generate the sentences, that is construct the sentences. Once the construction of sentence is made over, then how far it is correct, that we have to analyze. Those things we are going to consider under NLP, natural language processing. So if you consider in the universe, we have a big list of the communication languages among the humans, like Telugu, Hindi, English, Kannada, Japanese language, Russian language. These are all the natural language among the humans. So in these languages, the people will communicate. Every language we have certain formations rules. So the sentence will be formed based on certain rules. The formation rules generally known as grammar, right? The formation rules generally known as grammar. Now, if you consider in English language, we have a sentence formation like this: I eat fruit. So in this form, if you consider the simple sentence, maybe the word combination may be first one the subject, and the next one verb, eat is verb, and object is fruit. So subject, verb, object. This is the combination how we can able to construct a sentence in English language. The same method, the same structure, the same order of construction of a sentence may not be possible in other languages. Like suppose if you consider Telugu. In the Telugu, the same formation I can write it like this: Nenu pandu tinnanu. So in this one, Nenu subject and pandu, that is object, tinnanu is verb. So the order of the structural order of sentence formation will be subject, object, verb. In English, subject, verb, object. In Telugu, subject, object, verb. In some other language, maybe Russian, maybe German, so their language construction may be verb, object, subject, or object, subject, verb. Like that, it depends. That is defined by the formation rules, which is known as grammar, right? So similarly in the natural language processing systems, we have its own the sentence formation structure, that is given with a just like any language. We have some grammar structure, grammar rule, formation rules. In the NLP system, we have some production rules. So the sentence formation will follow a production rule that is known as LHS produces RHS. This particular form it will be, or this particular format also we can say that alpha produces the beta. What is alpha? What is beta? That is the contents of the language. That is maybe the words, different types of words, or different types of ingredients of the language that we are going to discuss shortly. Now, in the natural language processing system, it have its own production rule, the structural rules, that is alpha produces the beta, where alpha and beta are the ingredients of the language. And based on the general grammatical formation can be classified by their generative capacity. According to the Noam Chomsky, there are 4 types of grammars. They classified the grammars into 4 types. One is a type 0, type 1, type 2 and type 3. What are these types of grammar? Let's see. So suppose say the type 0 grammar means the grammar will have unrestricted rules. So there is no restriction on formation of the ingredients, like what is alpha, what is beta. And the language, the grammar which is unrestricted, based on that the language has developed means that is regularly enumerable language. That particular language is called recursively enumerable language. Now the language consists of so many words. The which word has to come first and which word has to come next, that is available in the grammar, that built up with some language, that is this grammar is presented for formation of sentences. That particular language is recursively enumerable language. So how this will be happen, how it is going to convert, the formation will be done by some mathematical model that is known as automaton, that is Turing machine. The automation system which can accept the recursively enumerable language, that is known as Turing machine. Okay. Next one, similar type of thing, that is a type 1 language. In the type 1 language, the contents of alpha and beta will have certain rules. Those rules we are going to discuss later. So it is having context sensitive grammar. The language, the grammar name is context sensitive grammar, and based on that the language formed, the construction of sentence formed in the language. That particular language is called as context sensitive language. And for the formation of this one, we are going to consider a mathematical model, so that is linear bounded automata. Then the third category of the grammar is known as context free grammar. And based on that grammatical the grammar, so the language is formed, that is known as context-free language. Context-free language. And for this formation of this one, the mathematical model which will accept this particular language is known as push-down automaton. And the last category, there is a fourth type of grammar, that is a type 3, which is known as regular grammar. So it is having some restrictions. The regular grammar having some restrictions. So that is what is alpha and what is beta. That we are going to anyway we are going to discuss that one, the formation rules, production rules, that we are going to discuss in the next slide. So the language which depends on the regular grammar is known as regular language. And for this formation of this one, the mathematical model is finite state automation. And in the last slide, we have the languages depends on the grammar. What the grammar contains? The grammar contains 4 types of words, 4 types of ingredients. So any language consists of 4 types of ingredients. Those ingredients that is for processing systems. That is for processing system. Any grammar consists of 4 types of systems. That is VTPS, where V is a set of variables, that is known as non-terminal symbols, and T is a set of symbols, that is a terminal symbols, and P is the production rules. How this formation, the type 0, type 1, type 2, type 3. So for formation of restricted, unrestricted, or the maybe context sensitive, context free, that depends on the production rules that we are going to discuss anyway. And some symbol like starting symbol. So these are the 4 tuples that is available for the grammar, any grammar, whatever the language we have discussed, we have classified for all these four categories of languages. So the grammar will be VTPS. One is terminal symbols, non-terminal symbols, production rules, and starting symbols. These are the this will constitute the grammar for any language. What is the type 0 grammars? Type 0 grammar means unrestricted grammar is known as type 0, that we have already discussed. Generally, it is this based on this, it is the what the language is formed means recursively enumerable languages, and it have no production, no restrictions on the formation of sentences. That is, the production rules have no restrictions. That is, I said the formation rule is alpha produces the beta. What is the alpha? What is beta? This is a combination. Alpha is the combination of terminals and non-terminal symbols. Beta is the formation of the combination of terminals and non-terminals. For this, there is no restriction formation of which terminal first, which type of the component has to put. That is terminal symbol or non-terminal symbol. Left hand side there is no restriction. Right hand side there is no restriction, and we can form any combination of terminal, non-terminal symbols for formation of the sentences. Right? So alpha is a string of terminals and non-terminals with at least one non-terminal, and alpha cannot be null. So alpha in representation of alpha, the left hand side, it may be terminal, non-terminal symbols, but alpha should not be null. Okay, at least one non-terminal. And the beta is a string of terminals and non-terminals. Again, a beta is, there is no restriction at all. So beta is a string of terminals and non-terminals. What is terminal? What is non-terminal? Terminal means the which cannot be further terminated. Non-terminal means it can be further discretized. So for getting the meaning of that. So generally, the non-terminal means we are going to use capital letters. Terminals means we are going to use small letters, right? In the type 1 grammar, it is based on the type 1 grammar based on the context sensitive. The name for the type 1 grammar is context sensitive grammar. So based on that, the language formula is context sensitive grammar. So in this one, the production rules are just like this. Alpha produces the beta. Alpha may be any combination of the terminal, non-terminal. Beta may be any combination of terminals, non-terminals. Here the restriction is the length of the alpha, the number of strings in the strings that represents the alpha may be the combination, the sum of the length of the alpha, that is a sigma alpha means the length of the string in the alpha should be less than or equal to the length of the string in the beta. That the number of the ingredients in the left side and the right side should be having some limitation. That is, alpha should be less than or equal to beta. So that is, left side should be number of the ingredients are available. That is, the components, the symbols are available. That should be less than or equal to the right hand side. That is the restriction here. The alpha beta may be empty, but the gamma should not be empty. So in this alpha A and beta, and alpha, gamma, beta. In this left hand side, the alpha, A, beta, and right hand side, alpha, gamma, beta. In this one, A belongs to non-terminal, and alpha, beta, gamma are the combination of terminals and non-terminal symbols. And the combination, anything is possible. The restriction is the left hand side should be less than or equal to right hand side. That is the restriction here. Here's in the example, capital AB. Capital AB is non-terminals, and capital A, B, B, C. That is the length of the right hand side. The length of the left hand side is greater than the string length, that is capital AB. The string length of the left hand is less than or equal to string length on the right hand. That is one thing. And at least in the left hand side, that is if you see A, second example, at least it should be one non-terminal. At right hand side, any combination we can put, right? And the terminals or non-terminals, any combination you can put on the right hand side. But left hand side, we should have one non-terminal. That is the thing. And similarly, the type 2 grammar. The type 2 grammar, it have its own restriction. That is, the production rule consists of alpha produces the beta, the same thing. So alpha may be non-terminal. Alpha, it should be a non-terminal. And the beta is the combination of terminals and non-terminals. For the time you can remember, non-terminal means capital letters, and the terminals means small letters. Non-terminal means capital letters, terminals means small letters. So here alpha may be capital letters, and beta may be combination of terminals and non-terminals. That is combination of both small letters and capital letters. And there is one restriction here. The right hand side, the terminal symbol, that is a non-terminal symbol, should be extreme ends. That is a capital X. It is a starting symbol, or it may be end of the string. If it is available in the combination beta side, that is the right hand side, it may start with the non-terminal symbol, or it may end with the non-terminal symbol. If it is a non-terminal symbol is available in the beta side, right hand side. Otherwise, if it is only having the terminals, then we can put ABC like that. Okay, so the right hand side, the terminal symbol should be extreme end, either left or right of the right hand side portion. That is extreme ends. It should be non-terminals on the right hand side should be extreme ends. And if it is not having the non-terminals, it may be terminals we can put. Any combination of terminals we can put. But the left hand side, you should have non-terminals only. That is the capital letters. That is the restriction here. And the third category of grammar is type 3 grammar. That is a regular grammar. Here we have a lot of restrictions. That is, left hand side we have non-terminals, and the right hand side it should be terminals. If it is a terminal means, if it is a terminal available means it should start with a non-terminal, and if it is any combination of that. Suppose say the first one is the X produces a terminal symbol A, or X produces the combination of terminal non-terminal, it may be AY like that. If the Y produces the B, so Y is a non-terminal, produces B, terminal symbol like that. Right? This is the type 3 grammar. So these are the production rules that we have for sentence formation. Now there is another language, the natural language for communication, because the natural language, so the language consists of the components of the natural language consists of words. The formation of words will become a phrase. Okay, so the natural processing system, it will follow a different structure, that is a phrase structure grammar. So the phrase structure grammar is a formal framework in the field of natural language processing, NLP, that describes hierarchical hierarchical structure of sentences in the language. So the combination of words put together in a meaningful form, that is a phrase structure. So this phrase structure, the combination of phrase structure will form a sentences. So there will be some particular way the how the natural language processing systems will be generated for forming the communication language, the natural language processing systems. It is a system syntactic model, that is a meaningful one, to analyze the and generating the sentences based on the arrangement of phrases and the relationship between them. The phrases may be the noun phrase and verb phrase, like that proportional phrase that we can put together, it will form as a sentences. For the arrangement of whether we have to use a phrase, noun phrase or verb phrase or noun phrase or proportional phrase. So based on that formation rules, the sentence formation will be followed. So in the phrase structure grammar. So the natural language processing, we are going to use phrase structure grammar, right? So phrase structure grammar, we have a set of formal rules typically expressed in the context-free grammar. What are the rules we had in the context CFG, context-free grammar? The same thing we are going to use for phrase structure grammar to generate sentences and the analyzing the sentences. The rules, the proportion rules, what we are going to define in the CFG is same applicable, but here the phrase structure, we are going to form the relationship between the variants of the constituents of the phrases, that is such as noun phrase, verb phrase, proportional phrase, the other adjectives and all these things. Suppose if we take any language, so in the NLP system, the grammar consists of the terminals, non-terminals, and the proportion rules and symbols, starting symbol. Suppose if you apply this one for the natural languages, the terminal symbols and non-terminal symbols. So terminal symbols means they represent the basic units of language, typically the corresponding to words and punctuation marks and other things. Whatever the language consists of, sometimes the words, basic term, and the terminal symbols represents the least part, lowest part, hierarchical structure. The lowest part is the words that comes under terminal symbols. These are known as lexical symbols. That is, any language consists of the collection of a big list of words. That words is known as terminal symbols. So for meaning of that one, this is the no further derivation is required, that we can remember. For getting the meaning, there is no further derivation, further discretization is not required. Each one have its own meaning. For example, in sentence, the cat sat on the mat. So in this particular thing, the terminal symbol should be the. Cat sat on the mat, full stop, all put together, all are the components of the sentence. These components are known as terminals or lexical symbols, often associated with the parts of speech tags to capture their grammatical role in the sentences. And what about the non-terminal symbols? Non-terminal symbols represent the language units of language, larger units of language, such as phrases or sentence structures. Indirectly we can put a combination of the words in a particular fashion that represent that is having a meaningful form, that is phrases, and it may be a meaningful form with a combination, maybe sentence structure. These symbols are defined by rules, especially how they can be combined to form the larger sentences. So there is, I already said, so noun phrase and verb phrase, the combination, and adjective phrase or proportional phrase. So put together which order we have to follow, that is given by the proportion rules. So non-terminal symbols do not appear directly in the sentences, but use it to generate or analyze the sentences. Suppose say if you take one example, the cat is sleeping. Here there are two terminals, the components. That is a non-terminal symbols and terminal symbols. Here non-terminal symbol could be like noun phrase and a verb phrase. So the cat is sleeping. Sleeping. The cat is sleeping. So noun phrase, the cat is sleeping is a verb phrase. Okay, this combination may be possible. So in the sentence, the cat is sleeping. Cat is sleeping. So terminal that is maybe noun phrase and a verb phrase. They put together, it will form a phrase, a sentence. So here what I told, phrase structure rules. Phrase structure rules define allowable combination of terminal and non-terminals. They determine how the constituents can be combined to form larger constituents and ultimately build a complete sentence. These rules describe syntactic relationship between the different components of sentences. To understand this one, let us take one simple example for phrase tree structure grammar. Let us take one production rule. So production rule means a sentence is formed with a noun phrase and verb phrase. The rule one states that a sentence S can be divided into noun phrase followed by verb phrase. That is the rule. The constituents of NP and VP can be further expanded using the grammar rules. For instance, NP can be further expanded into a preposition and a noun, determinant or preposition and a noun, and a verb phrase can be further expanded like verb phrase and a noun phrase, or verb and a noun phrase, or simply verb. We can form the rules. So as per the second rule 2, it indicates that the noun phrase can consist of a determinant, that may be a preposition followed by a noun. That is the rule. And the third rule is state that the VP can be, that is a verb phrase can be formed by verb followed by a noun phrase. So these are the production rules. So let us take one example. The cat eats fish. So the entire sentence represents the yes. That is rule 1. The entire sentence cat eats fish is entire sentence represents the yes. The sentence is formed with a noun phrase and verb phrase. So what is a noun phrase and verb phrase? Noun phrase, if you expand, then it will be determinant and noun phrase. Verb phrase can be expanded. There is a verb and noun phrase. That is, we can expand. We can show this one in the tree-like structure. I will show this one at the end. Then in the last way, now we can substitute. The determinant of preposition is the noun can be cat, verb can be eats, and the noun can be fish. Noun phrase can be fish. The cat eats fish. So this particular way a sentence can be formed. Here the production rule is yes should be the combination of noun phrase and verb phrase. Left side should be non-terminal, that is yes. Right side should be terminals, noun phrase and verb phrase. So the same structure, if you want to analyze the sentences, once the sentence is there, then we can able to analyze by using the bottom-up approach. That is, the sentence is available. If you discretize this one, say from the bottom to the top root, so we can able to analyze the sentence whether the former sentence is correct or not. Also, we can able to apply. We can able to do that one. We can able to analyze that one. Right. This is about the what you call the production, the context free, the phrase structure grammar. So now the phrase structure grammar, we can able to generate any sentences. But the thing is, if you have for a particular situation, if you have formed 4 sentences, which sentence is the best, that we can't able to, that we have to find means, then in the PSG is modified with the probabilistic application, probabilistic concept. that is a CFG is further extended with the probability concept. Now this language is PCFG. The language grammar is PCFG. That is a probabilistic context-free grammar. A probabilistic context-free grammar is formation used in the natural language processing and the computational linguistics to describe the syntax of the language. So it is the same thing, the CFG, and associated with the probabilities with the production rules. So what is the difference means? So each constraint is provided with some probability value. There is a production rule is augmented with the probability value representing the likelihood of choosing that rule. The probabilities that allows us to model the likelihood different syntax structures and generate sentences that are more likely to occur in natural language. Here is the one example. So PCFG, if you consider the language format, so in this grammar also we have four types of tuples, that is terminals, non-terminals, and production rules, and the symbols. So here the V is a non-terminal symbol, T is the terminal symbol, P is the production rules, where alpha is a non-terminal symbol, definitely it should be, and beta is a sequence of terminals and non-terminals, S is a symbol, and the production release alpha produces the beta, same formation, but this rule is represented the P within the P is provided, probability P for production of alpha produces the beta. For producing the alpha from the alpha to beta, what is the probability that is given with some likelihood value, that is a probability value. So that is only the difference. Now we can see for formation of this one, the lexicals. So suppose say if you consider an English language, the words what is available, that is nothing but lexicon. Lexicon, a list of allowable words. Suppose if you consider E0 means English language, when come to lexicons of English language, that is E0. So in the English language we have a collection of words. These collection of words is nothing but lexicons. The words are grouped into lexical categories familiar to dictionary uses. That is noun, pronoun, so on, name, so that belongs to one particular, and verbs, events that represents the events, adjectives to modify the nouns, adverbs to modify the verbs, functional words, that is articles, propositions, conjunctions. So all these things what is available in the language, in the English language, that represents the lexicons. Suppose if you consider a particular language, in that what is the occurrence of each word, that is given with a brackets with a probability value. So in the particular thing, a noun is given, nouns are trench, breach, vampers, pits, all these given with the formation of sentence with a probability, and the verbs, feel, smells, stings, all these things with some probability. All the words, what is the probability of occurrence in the language, that is categorized, that is available with a probability value. These are the lexical categories. Now, so for formation of the sentences, we have certain rules. That is, S is the sentence, that is a combination of noun phrase and verb phrase. For the noun, for the sentence formation, the probability is 0.9. If you follow, I feel a breeze. I is a noun phrase, verb phrase, that is a feel a breeze. If it is the sentence is formed with a noun phrase and verb phrase, then it is a there is a positive 0.9 probability. If the sentence is formed with a sentence with a conjunction with another sentence, then the probability of formation of sentence is 0.1. Similarly, there is another the syntactic category, that is a noun phrase. Noun phrases, pronouns means it is a 0.3 probability. So noun means 0.1 probability, and for each one, so what is the probability of forming the sentences in the noun and the different variants of noun? So what is the probability that I have given? So these are the things available in the PCFG, that is a probabilistic context-free grammar. So with now these values we can form the sentences. Suppose say every vampire smells. So the entire sentence is yes, that represents the every vampire smells. So here every vampire smells. So noun phrase is article and noun. Noun phrase is formed with the two terms. One is a article and noun. For that article, if you use a noun phrase with the article that are given with the 0.05, here the article is given with the 0.05. So noun phrase is formed with an article that is given with the 0.05. So now we can consider the probability of 0.05, and noun phrase is 0.15. What is the happening of every? What is the happening of Wampus? So the noun is formed with the combination of that one. The formation of the sentence is 0.25. So if you use every, that is 0.05. If you use Wampus under noun, it is 0.15. Similarly, in the verb phrase, the verb phrase is formed with the verb. So that is a 0.4 probability, and if it is a smell is used, its a probability is 0.1. Now if you multiply all the probabilities of occurrence, then the total probability of occurrence of the sentence which can be acceptable will come. That is a 0.00675 will represents the probability of formation of sentences. So from this, like this, we can able to create any sentences with the probabilistic value. So this representation also given with a tree-like structure. So sometimes a sentence can be formed, maybe sometimes it may not be meaningful. Sometimes but it is a grammatical correct. Sometimes it may be grammatically wrong, but it is a meaningful. There are two situations comes in the formation of the sentences. So those things can be happens. Those things are classified into over generation and under generation. Over generation grammar means it is the sentence we can generate with a good meaningful form, but the grammatically it is wrong. Over generation means the sentence can be generated, but grammatically it is wrong. So over generation occurs when the grammar or language model produces the sentence that are grammatically incorrect or not meaningful in the given context. It often happens. So that is a over grammar means grammatically correct. Maybe meaningful wrong means that is the under generation. It often happens systems has learned the patterns that are too the permissive or lacks of sufficient constraints. So in the formation of sense. So for example, here you take, so it's a over generation. This is the example for the over generation. That is, I go to market yesterday. So here instead of the go or went, we are using goed. Generally it is formed like worked. So ed is added. That is added with the verb formation. So it is wrong. But the meaningful form, it is more or less it is giving some meaning, but it's grammatically it's wrong. That comes under over generation. In the under the over generation, under generation criteria, if you consider over generation means it may be grammatically incorrect. It conveys some certain meaning, but it's not meaningful in the language context. So it is conveying some meaning, but if you go for in depth, it's not meaningful in the given context. So it often happens when the system has learned the patterns that are too permissive or lacks sufficient constraints. There is a formation of the sentences. So in that, what happens means, if it is a over generated system, over generated means it will happens because of not having the constraints over the formation of sentences, the grammar, and the system may be over generated by following creation of non-standard web forms. So this is about a over generation. That is, it is grammatically wrong, but because of that it is not conveying some meaning. But here the grammatically it is correct, but it is not producing the right form. Train going, platform coming. Train is going, platform is coming, like that also. Train is going, platform is coming. But the sentence wise it is a meaningful, it is not coming in the conveying the message, we are going to reject it. The train is coming, or train is going, platform is coming, like that. the train is going, platform is coming. So in that the sentence form is grammatically correct. But due to overly strict rules, lack of knowledge about the valid constraints, and because of this, it will produce the sentences that are valid grammatically, and it cannot convey some correct form of formation. That is, the formation may be grammatically correct, but the language point of view, we can't able to use that one. We will reject it. This is about the under generations. So these are the topics that we have covered under phrase structure grammar. So if you like this video, you can share, subscribe, but don't forget to give me a like. Thank you. So again, we'll meet in the next video on the some other topic.